Hello everyone, good day. My name is Brian Dave Gasok, a BS in Mathematics 3A student of Papalong College of Agriculture, Sciences, and Technology. So for today's video, I'm going to discuss the set operations. So now, let's start. So set operation, what is set operation or what are set operations? So set operations are concepts similar to fundamental operations and numbers. Now, sets in math deals with a finite collection of objects, be it numbers, alphabets, or any real objects. Sometimes a necessity arises wherein we need to establish the relationship between two or more sets. So there comes the concept of set operations. So there are four main set operations, which include set union, set intersection, set complement, and set difference. So in this article, we'll learn the various set operations, notations of representing sets, how to operate on sets, and their usage in real life. So what are set operation? So set operation is a set is defined as a collection of objects. Each object inside a set is called an element. So a set can be represented in three forms. So they are statement form, roster form, and set builder notation. Set operations are the operations that are applied on two or more sets to develop a relationship between them. So set operations, So this is an example of using the three forms. So as I said earlier, as I've read earlier, that there are three forms of use or three forms in representing the set. So these are the statement form, roster form, and set builder notation. So in this example, we see that a set consisting of all even positive integers less than 11. So meaning positive even integers. So they are the 2, 4, 6, 8, and 10. So since it is less than 11, so it will end at 10. So in our statement form, this is how we state it as a set. So a set consisting of all even positive integers less than 11. So in a roster form, we will include all the elements. So we have here 2, 4, 6, 8, and 10. So in a set builder notation form, we will represent a element wherein we need to state an x. So a set of x where x is an element of positive integer, where x is even and x is less than 11. So that's how the set builder notation form be stated or be written. So next we have there are four main kinds of set operations, which are as follows. So we have here union of sets, intersection of sets, complement of a set, difference between set or relative complement. So before we move on to discuss the various set operations, so let us recall the concept of Venn diagram, as it is important in understanding the operations on sets. So a Venn diagram is a logical diagram that shows the possible relationship between different finite sets. So the Venn diagram can be represented as follows. So we have here a Venn diagram. So as we can see, the rectangular object or shape represents the universe. So because it encloses all the set of objects in the universe, so it's called universal set. So inside are the two sets of objects, which represented as set A and set B. So however, the elements are distributed in the diagram depends on each groupings, and the relationship will be determined through the set of operations. So that's how we're going to use the Venn diagram, and that's how important Venn diagram in this set operation. So these are the basic set operations. So now that we know the concept of Venn diagram, so let us discuss each set operation one by one in detail. So the various set operations are, we have here first the union of set. So the union of set states that for two given set A and B, A union B is the set of distinct elements that belong to set A and set B, or both. So the number of elements in A union B is given by, here's the formula for our union of sets. So n of A union B is equal to NA plus N set B minus the N intersection of A and B. So where nx is the number of elements in set X. So to understand this operation of the union of sets better, let's consider an example. So here's an example. If A, so we have here set A and set B. So in set A, we have 1, 2, 3, 4 elements. So these are the elements of set A. Whereas in set B, we have 4, 5, 6, and 7. So then the union of A and B is given by A union B is equal to 1, 2, 3, 4, 5, 6, 7. So how did we attain that answer? So okay, through combining the elements of A and B, so we made union through the objects in sets, in each set. So also, as you can see, there is a repetition of elements, which is 4. But in union of sets principle, elements in a set should not be repeated. So just indicate 4 only. So that's how we attain the A union B as 1, 2, 3, 4, 5, 6, and 7. So this is just a combination of numbers or elements in two sets. So next we have the intersection of sets. So intersection of sets for two given sets, A and B. So A intersection B is the set of common elements that belongs to set A and B. So the keyword is common element. So the number of elements in A intersection B is given by, so these are the formula for our intersection. So A intersection or N A intersection B is equal to N set A plus N set B minus the intersection of A and B, or N intersection of A and B. So where Nx is the number of elements in set X, so just like the union of set. So to understand this set operation of the intersection of sets better, so let us consider an example. So we have here an example as well. So we have two sets with its elements, just like in our union of sets. So here we will find the intersection. So if A is equal to 1, 2, 3, 4 and B is equal to 3, 4, 5, and 7, so then the intersection of A and B is given by A intersection B. So 3 and 4. So the intersection here is 3 and 4. So why did we say so? So consequently, unlike the union of sets, here in the intersection of sets, we get the common element. So in the two or more sets, just like in the example. So as we observe, both 3 and 4 are elements of set A and set B. Thus, these two elements are their intersection. So it's clearly evident that we see that 3 and 4 is a common element of set A and set B. So that's how we obtain the intersection of the two sets. So next we have set difference. So in set difference, set difference. So the set operation difference between sets implies subtracting the elements from a set, which is similar to the concept of the difference between numbers. So this difference between sets A and B denotes A difference B, or dash B. So lists all the elements that are in set A but not in set B. So to understand this operation or set difference better, let us consider an example. So here, if A is equal to 1, 2, 3, 4 and B is equal to 3, 4, 5, and 7, so then the difference between set A and B is given by A difference B 1, 2. 1 and 2. So how did we say so? In the sample given, this set operation would like to find the difference of the set A in set B. So meaning, you will find the elements in the set A that are not elements of set B. So here, as you can see, elements 3 and 4 are in set B. With that in hand, we can actually say that the elements that are not in set B are 1 and 2. Therefore, the difference of A and B is 1 and 2 respectively. So next, last set operation, we have complement of set. So the complement of a set A denotes as A complement, or A raised to C, or apostrophe. So read as A complement is defined as the set of all the elements in the given universal set U that are not present in set A. So to understand the set operation of complement of sets better, so let us consider an example. So if U, or a universal set, 1, 2, 3, 4, 5, 6, 7, 8, 9, and A is equal to 1, 2, 3, 4, then the complement of set A is given by A apostrophe, or A complement is equal to 5, 6, 7, 8, and 9. So it is just easy to understand how we attain the answer here because it is just similar with the difference. However, here in complement of sets, you will compare a set of objects in universal set. So given the sample here, looking at set U, you will just crush out the numbers that are belong to set A. So thus, the complement of A are the elements that are not in A but in U, or universal set. So that's why we came up with the answer of 5, 6, 7, 8, and 9. So next we have here set operations. So the image shows various set operations with the help of Venn diagrams. So it is clearly shown that the first figure shows the set A. So that's why our set A is only the shaded part of the figure, so because it shows the set A only. So in the second figure, set A and set B are joined together as union of sets. So it is a representation of a union of sets. So in the third figure shows the intersection of two sets, shading the portion in which they have elements in common. So in the fourth figure, it shows the complement of set A, or of set A, wherein shows all the elements that are not in A are said to be its complement. So in the fifth figure, when the elements of one set B completely lie on the other set A, then B is said to be a proper subset of A. So lastly, when the two sets have no elements in common, then they are said to be disjoint sets. So now let us explore the properties of set operations through an example. So but before that, we will have here important notes on set operation. So set operation formula for union of sets is, or the formula here in your union of sets is n of A union B is equal to n of set A plus n of set B minus the n intersection of A and B. And the set operation formula of intersection of sets is n A intersection B is equal to n set A plus n set B minus the n union of A and B. So let us remember this formula because it is really helpful and it's really useful in solving set operation problems, especially when we're going to talk about groupings or sets. So the union of any set with a universal set gives the universal set, and the intersection of any set A with a universal set gives the set A. So union, intersection, difference, and complement are the various operations on set. So the complement of a universal set is an empty set, or we have here a U complement is equal to an empty set, all null set. So the complement of an empty set is a universal set. So reversibly, so the complement of our null set is just a set U. So now let's proceed to our examples. And example number 1, in a school, so every student plays either football or soccer or both. So it was found that 200 students played football, 150 students played soccer, and 100 students played both. So find how many students were there in the school using the set operation formula. So this what I'm saying a while ago, that it is important to know or to remember the formula for our union intersection, because it's really helpful, especially in this kind of problem solving. So solution, let us represent the number of students who played football as n of f. So, and the number of students who played soccer as n of s. We have values of our n of f as 200, so as stated in the problem. So, and our n of s also we have 150, and our intersection of f of s who played both the sport is 100. So we know that the formula for our union is n union of f and s is equal to n set f plus n of set s minus the n intersection of f and s. So therefore, n of union f and s is equal to 200 plus 150 minus 100. Just substitute the values. So 200 plus 150, we have 350. So minus 100 is equal to 250. So hence, the total number of students in the school is 250 using the formula. So next, we have example number 2. If A is equal to, so we're given here a sets of A, B, and a universal set. So in our set A, we have A, B, C, D, E. In our set B, we have A are the vowels A, E, I, O, U. So in our universal set, we have A, B, C, D, E, F, G, H, I, J, K, L, O, and U. So perform the following operations on sets and find the solution. So here we will find the union of sets, the intersection of sets, the complement of A, and the difference of A and B. So we have here a solution. So in our union of set A and set B, we have obtained the solution of A, B, C, D, E, I, O, and U. Why is that so? So remember that in our union of sets, we will just find, or we will just combine the elements of the sets. So here in our set A and set B, we have a repeated elements, which is A and E. So in our union principle, let us not write it down as repeated numbers. So let us just write A and E once in the number of elements in our set union of A and B. So now in our intersection, so let's just get the common elements in A and B. So as we all know, so we have the repeated elements A and E. So that's their intersection. So that's why we obtain A and E as the elements of our A intersection B. So in our A complement, so as we all know that the complement of A, that the elements of universal set must be distinct. So that's the complement. So it's a distinct elements of set union, wherein there are no elements of the set A. So let us just crash out the element of union set, which is also an element of our set A. So here we will crash out A, B, C, D, and E. So that's how we obtain the complement of A as F, G, H, I, J, K, L, O, and U. So lastly, our A difference B. So we will just get elements in our A that is not an element as well of B. So as we all know that the intersection, they have the common elements A and E. So let us crash out A and E in our set A. So the remaining numbers the remaining elements are B, C, and D. So that's how we get the difference of A, or set A and set B. So thank you everyone. So I hope you learned something and you gain knowledge of set operations, because it is really important as you're going to discuss or explore more about the set operations, or when we explore more on our topic, which is set. So there are more to discuss about sets, but these are just set operations in which very helpful and useful when you're going to deal with our sets, or how to solve the relationships of these sets. So I hope you enjoy this video. Thank you and God bless everyone. Thank you for watching. Bye bye.